Just to continue regarding the scenario and the vision regarding hydrogen, we've got an international guest, Professor Petteri Laaksonen. Just to introduce him, I'm going to say a few words in English.
We're very happy to have your participation in this seminar about energy storage system and green hydrogen. Petteri Laaksonen is a research director at Energy System School at Lappeenranta University of Technology, LUT, in Finland, with a focus on renewable energy system and power generation in view of industrial engineering and economics. Professors, again, thanks for your participation here in the seminar. The time is yours.
Okay, thank you very much for this opportunity to make this presentation to you. I'm honored to be as a guest speaker here in your seminar. And it was some years ago, I was actually visiting there in Santiago de Chile in Wärtsilä's seminar. And it was about pretty much the same issue that we were discussing. Shortly, what we will strategy. We see that there are issues that are very much related to the Earth and what to do to save the Earth. So from our point of view, it's actually, and it's also the emissions that are in the air, CO2, and how these could be turned into opportunities. And then, of course, water will be a big issue. So how do we refine connected to making business? Simply our strategy. And okay, then even though we are quite young university, only 50 years old, we are part of the top 200 universities of the world in the impact ranking of Times Higher Education. So what we do does have an impact. And I was asked to talk about green electrification and especially the hydrogen economy. But we are very much into power to X. So how do you make products from electricity? And that's one of the leading things we do in Europe. How to electrify things. And this is the main, I would say, part of the story. Hydrogen is electricity. It's stored in a format of hydrogen, and it can be used as in form of hydrogen. This story is maybe confusing. It starts with the blank electricity, and we talk about cheap green electricity in huge quantities. That's the future. So we have clean electricity. That's the sort of energy that we will use instead of using fossils. Globally, we are using something like 15% of electricity and 85% of fossils. In the future, it's the other way around, or even more of electricity. And electricity is the source of everything in this new hydrogen economy. And if we go further from electricity, we have two areas where electricity is actually the heating and cooling. If we look at what you get from electricity in transport, sort of energy to wheels, it's about 75%. And if we talk about heating, especially heating, but also cooling, the power factor is actually 300–500%. So 3 to 5 times more heating or cooling from electricity. Going further, we go to electrolysis, and then we are producing hydrogen. Then efficiency of production of hydrogen is about 65% of the energy. The other part is going to heat. So we will have a lot of heat. If you say that you will have 5 gigawatts of electrolyzers in the future in Chile, it means that probably 1.5 gigawatts is going to heat. So it has a great impact on heating and a whole sector of heating. If we go further from electrolysis, then sorry, I can't see that very much, but hydrogen is very much a clear product for especially steel industry. So using hydrogen as instead of coal for reduction of oxygen in the process, it actually can make clean steel. So it's green steel from green energy, green electricity. And further on, we can use hydrogen also in the synthesis and bioprocesses. When we're talking about production of fuels, either they are based on nitrogen or CO2, we can actually produce fuels to replace existing systems fuels, and we don't have to change the whole system. So we can produce with the synthesis gasoline, kerosene, and diesel for existing sort of equipment. So we don't have to change the whole system to do that. It means that we have to take CO2 from somewhere. It can be actually coming from air. I don't know if you see my pointer here, but it can come from air. It can come for different industries, cement industry, and it can be captured from the point sources and synthesized with hydrogen to fuels. Further on, we can actually do hydrogen directly, but I can't see that hydrogen would be a solution, for example, for heating, because with these efficiencies, you get only 32% of the energy into heating, for example, when you have actually 10 times more if you do it directly with the electricity. And the same thing applies also to transport. So if you do the hydrogen with the electrolyzer with the efficiency of 65% and maybe get 65 or 50% of that, it is about 42%, which is only a half of the efficiency that actually electricity will bring to you. It means that the car or lorry that you would buy would actually cost every kilometer twice as much as with the electricity. So hydrogen is not actually the best solution to buildings or transport. But if we go further in the synthesis processes, methanol and ammonia from nitrogen and methanol from CO2, they are both very important raw materials for chemical industry. Olefins, for example, are part of the methanol route, and they can be used in plastics. So we can produce actually carbon neutral chemical industry. We have already done food, so we use microbes in the bioprocesses, only hydrogen, CO2 and microbes, and then you can produce food. So it will have a big impact in agriculture too, not only through the ammonia route to fertilizers, but actually real food from the synthesis processes. And that's about 100 times more efficient route to produce food than actually on the fields, the crops on the fields. And then everything will change also in the manufacturing industry because there will be a huge demand of different kind of new equipment. In the end, it has an impact to finance, policy, and then geopolitics also. But this is the picture that what is happening and how the hydrogen is part of these processes. We have to keep in mind that the whole issue is about cheap electricity. So if the production of electricity is let's say $10 or euros per megawatt hour, then hydrogen is about 15. So because of the efficiency, it means that the price goes up. And the next question is in the markets that where is actually the competitive advantage to different countries. And this is the next picture that I have. So it is actually location related competitive advantage. So we are talking about production of hydrogen and then as an end result, for example, fuels. But if we look at the picture and we produce electricity, let's say with 20 euros per megawatt hour, this is the production cost. And you use it directly to electrolysis on site. The cost of hydrogen would be 33 euros per megawatt hour because of the efficiency. So the rest is going to heat. Now, if we are using it at that site, then we don't have any other costs. But if we go and this is the route. So it is the same if it's in the storage and it's used. But if it's go to shipping or it is transferred with the pipeline, there's an additional cost. And then if you look at this simple part of this, it has actually three prices already in this storage. One is the direct price at site. One is actually shipped. So there are losses of efficiency or piping, and there are losses of efficiency in compression of hydrogen. So there are different prices, and that means that there are different competitive advantages also for the production. So if you do all these steps on site from the beginning to the end, you don't have these extra costs for shipping and pipelines. But if you do it so, there's always an additional cost. And if you look at then where is the demand and where is the customers, then there are different prices to customers. And that means that there's a competition between countries to produce different types of as cheap as possible prices for hydrogen. If we go further and we start actually transferring the electricity, then we have different prices for the electricity, and the same efficiency with electrolyzers, it actually makes the price higher. So if we do the grid connection, let's say 500 kilometers in power grids, let's say average, it's 10 euros per megawatt hour. That's a figure only. It can be something else. But there you can see that the price of electricity is 30 instead of 20 in the previous sort of route. And then if you go to electrolysis, then it's 50. And then if you have any other sort of costs, the cost of hydrogen has now 5 different prices. And this is the question that where is the competitive advantage to produce the hydrogen with the lowest price to the customer? So it's not actually the production cost, but it's a cost to the customer. We go further and we want to do the CO2 capture from different sources and go to utilizing it. Then it's, do we do it on site, which is again on the same site as the electricity would be on this route? It would be there. That would be zero price, but only the capture price. But again, if we have to transfer it, there will be a transport cost, and then the storage has 3 prices there. Going further, then it means that if we have 5 prices for hydrogen and 3 prices for CO2, it means that there are actually 15 different alternatives for the end products, which is the fuels. And this means that the competitive advantage is actually very location related. And the question is also that the further you go in this process, especially I think in Chile, and this is actually very much to Finland, similar to Finland, that instead of us sort of transferring this electricity to Germany, for example, where the demand will be big, instead of that, we could actually do all these things to synthesis in Finland, and then only transport the end products. And this is the question that you should also, to my mind, consider in Chile, that what is the most beneficial for your country in this game. It's not actually the hydrogen only, but it's what is the best price that you can get for the products. And if you produce it on site all here, then you don't have this additional shipping and transport and grid costs. And further on, there are other issues, that how much operation time you can have and what kind of flexibility it produces to the markets and so on. But these 2 pictures were only to sort of, to my mind, open up what is the future hydrogen market and demand. And one more issue is that when you go into markets, who is the customer who can actually then offer you, let's say, 20 years purchase agreements, so that you have the security that this guy will buy all my hydrogen for coming 20 years. This is a big issue to my mind, because if there is no market, or there is only market for a certain period, there's always the risk on this investment. Okay, I'm not going to go further on this. This is just a list of things that we have done. I said that LUT is leading Power-to-X university in Europe. That's our own statement, but we have done quite a lot. Since 2014, we have done projects on this, and we have a leading team of energy transition modeling guys. We have about 25 people and led by Professor Christian Breyer. And we have done, for example, this with Wärtsilä project, Nebraska, where we actually looked at excess hydrogen coming from their production. What could we do? It was the same as I explained earlier, that Power-to-X products, it was about what to do with hydrogen further on. And actually they started a startup in Nebraska to produce fertilizers. Recycling of CO2 at ST1 refinery at Göteborg, and then we have research projects going on. If we look at this Carbon Neutral Finland report, we actually made this report together with Wärtsilä and ST1. They are big companies in Finland. Wärtsilä is as well known globally, and it was about how to utilize the CO2 sources, point sources from pulp mills in Finland. And in Finland, we could actually produce twice as much fuels as we would use ourselves. So we could actually be independent on that sense, as was mentioned also in your targets in Chile, and then also export the same amount to outside Finland. We just finished a feasibility study for industrial pilot of carbon neutral fuel production, and I was running this project, so I put also the link to that report if you are interested in. It is much more in details that how it could be done, what is the cost of the production, what are the producers of the equipment, where you can buy it, what is the level of technology, and basically it is actually on TR level 9, meaning that you can buy it off shops and so on. But you can find that if you're interested. We have just established a new company, this Neovolt, which is about power electronics in electrolysis and how to improve the efficiency of using electricity in production of hydrogen. As I said, it's 60 to 65% efficiency. If you can improve that by 3 to 5%, then you are winner in the game. We are working on carbon neutral Åland. Åland is a archipelago island. It's half independent, and they have a potential for 500 offshore turbines there, and 6 gigawatt production of offshore wind. And we are helping them to do a strategic roadmap to how to proceed, and so on. We have Bethnia Bay, Hudson Valley work going on, and then we are doing some other things. But just to say you that we are very much into this, and we have been working quite a lot, and we see that this is a strategic transition, and I'm delighted to be in this. I'm happy for you because you have a lot of green energy available in Chile, and I know that you will be also the winners in this game. Thank you very much.
Thank you so much, Petteri. Very impressive, your presentation, very interesting. I have a couple of questions, if you don't mind. First of all, it's very impressive. What are you doing at the university? I am also a professor at the university in Chile, so we are working in a couple of things related to your presentation. But my question is in order to the market in Chile, especially because you mentioned Chile a couple of times. So and also you said that we have quite a lot of green energy. So, but what would be your recommendation in order of research and development to improve the market of hydrogen? For instance, we are working in improving the electrolyzers, the electrolysis from water, but there are still some technological development that maybe you can guide us or recommend to Chile to improve, to go to the market in the following years. What would be your recommendation in this sense?
In a way, this is a pretty similar sort of question that we are now working on this Åland project. When we are talking about production of electricity, this is the starting point always, that we need to have that electricity to do hydrogen. So first of all, you need to have somebody who wants to have hydrogen, and you have to have a contract with that person. So PPA type of power purchase agreement type of a contract with the customer. for 20 years, for example. And then at the same time, when you get this kind of thing, you make also a contract with the producer of electricity for the investment of that new site to produce electricity. Either it's solar or it's wind. So you have to change these things to manage the risks in the investments. And this means that you have to have very reliable partners, because these partners must work following 20 years together. In Nordic countries, we have a good electricity market. It's very well connected, and we can actually sell the electricity in our sort of electricity stock exchange or exchange. But hydrogen doesn't have that kind of sort of possibility. It means that you are more or less related or reliable, or depending on one customer or two customers, because there is no grids to actually transport the hydrogen. And this is, to my mind, the key issue from the investor's point of view, that if you can actually manage this kind of chain of production of electricity, production of hydrogen, and the customer who is reliable, so that you can actually rely on that stays, then it starts. Was this an answer to your question?
Yes, very, very well. Thank you so much. I have one more question, if I have time, Manuel. Just a short one. You also mentioned. Thank you. You also mentioned the synthetic gas, right? So also in this sense, what would be your vision to Chile in terms that if we, for sure, we will follow the electrolysis from renewable energy market, but what about the transition, the energy transition? Everything related to carbon capture and synthetic gas probably is in the way of the energy transition. So what would be your I mean, this is for our point of view, but what would be your vision to the future in this sense?
Well, first of all, if we compare, let's say, methanol and methane, so gas or liquid, they are almost the same from the efficiency point of view to produce. And methanol is a very good source of very many sort of products. So it goes through olefin route, it can go to plastics, it can be used to the fuels, from the olefins to fuels route. So you can produce gasoline, diesel, kerosene for the existing infra like airplanes or transport, and that would be then carbon neutral. So to my mind, we have to look at the future in a way that we have to solve this issue in 15 to 20 years. And we can't replace the infrastructure in that time. It's impossible mission. So the only way is actually to replace the fuels and the raw materials with these kind of synthetic carbon neutral products. In that sense, I would say that, okay, methane is used quite a lot, and there's a lot of discussion on that. But methane is also, from the climate point of view, it's very bad. So if you have leakages, it's 84 times or 86 times worse over 20 years than CO2. And you never can avoid the leakages. When you go on the liquid route, that's not a problem in that sense. So from my point of view, I would say that with, again, looking at the markets, what kind of opportunities there are, methanol would give you much more opportunities from the customer's point of view than methane. Methane is just gas. You can burn it. Okay, if you burn it, then it's a renewable burnt and recycled CO2. But if you take then the methanol route, it can actually go into very variable routes and has a lot of opportunities from the customer's point of view. Does this give an answer?
Yeah, sure. Thank you so much. Thank you so much. Gracias, Manuel.
Muchas gracias, profesor.
Thank you, Professor Petteri Laaksonen. Thank you, Patricio, for the questions asked. To take advantage the presentation